Hello and welcome to another episode of Remote Pair Programming. I have Bastien again with me, and today we will continue the idea with the tested to tell a story. Let's have a short discussion about what we've done yesterday, last time, and what we want to do now. Let's go a bit on the code and see what we did.
Hi. So we implemented several features. We first implemented a few tests around how we want to deposit money on an account. So we had a very simple test around how when we create an account, it has no money. Then we experimented on how things would happen when we would deposit some money on an empty account, and then what would happen if we added more money on this account. So what I like about this test is that it tells a whole story of what will happen when you have an account and you create it, and then you add money, and then you add more money. So it really makes sense and help people to understand what the code actually does.
Mm-hmm. So we're telling the story of the code now with these tests. That's the idea.
Yes, we can have a look at the code. So account is rather simple. We have the deposit function, and then we implemented the withdraw function. We'll see that a bit later. We had a money class so that we don't have to handle how we can add some money to more money, and we can easily compare money to other money, and this way we can handle about any kind of money. So we don't have this kind of problem where we don't know if we want money to be in some currency or in another one, and this is just something that is money's problem and not account's problem.
Mm-hmm. We didn't define yet, in fact, currencies or stuff
No.
like that. We didn't define anything that's a detail of money, just the concept, and that's all. And I think it's enough for now. Even for a statement, I think it's enough.
Yes, probably. But anyway, what I like about this is that if we want to introduce the concept of currency later, it would be rather easy with this design.
Mm-hmm.
Now about the withdrawal, well, we didn't name the test correctly, I see. It was still work in progress.
Yes.
And so we wrote like 4 tests. The first one, which is that I can withdraw some money on an account on which I have made a deposit first. So this is a standard case, I would say. And then we wondered what would happen when we cannot withdraw enough money on an account. So we introduced another test for when we can actually withdraw money, and this allowed us to somehow extract the concept of what the withdraw function should return. And we went for a message, and then we can handle the way things happen when we do not have enough money in an
Mm-hmm.
account, which is another different message. And then we check that when we fail to withdraw money on an account, the amount of money on the account stays the same.
Mm-hmm. Okay, so these are the tests. And I think that's all right.
Yes.
So let's look at what we want to do next.
So we can implement the transfer function, which means that we would like to transfer some money from an account to another.
Yes.
It should be quite easy to implement given all what we already have. And then maybe we'll go to implementing account statements, which can be done in many different ways. And I think that the stories that we will tell may lead to some design, but at some point we will have some choice of how we implement things that do not come from the test. So this is interesting, I think, because When we do TDD, often we tend to forget that at some point, yes, we have to um, think of what design we want and see if it is easy to test or not. And many times there is not just one good solution, but you can do many different ways and have nearly the same test. So I'm curious to see what we are going to experiment on how to implement this feature.
Yeah, I'm
And how,
curious as well. I've done it once, I think, but it was very simple. For this, I mean, the implementation was very simple, and it was almost correct. But I'm curious to see how things will evolve.
yes, and at this point I would like to write tests that are really far from the implementation. I like that we would be very happy if we succeed in writing tests that is not coupled with the implementation, because this is something that uh, allows us then to make very easy refactorings and change the structure of the code and being quite sure that we are not breaking anything.
Yeah, sounds great.
So let's start with the transfer.
Yeah.
Maybe we should write a new class test, and let's just leave the deposit and withdrawal tests the way they are, because I don't think it's very interesting that we
Yeah,
do
for sure. So I would just rename that one the test because it's annoying. And then I would go on with so withdraw money on an account. Yeah.
Okay, transfer money from an account to another.
We have here business wise again. I'm putting my hat as a business analyst. We have several situations, many of them in fact, but let's say that the simpler one are when they're my own accounts, and that's easier to check because I can check that from my account money also got into the other account. And also there's a situation where I need to give money to someone else, and then I cannot check that someone else's account anymore because maybe it's another bank. So I just can check that I sent the right amount.
Okay. Which one do you want to do? Let's do
The first one because it's simpler, I think. Yeah. So we need two accounts, I guess, and for these two accounts we want to transfer some money that's different than zero, and it needs to be positive, a positive amount. And we need to check two things: one, that money got from out of the first account, and the same amount got into the second account.
So I'm writing what you're saying, and then we'll see about how we name things. So you want to transfer something like this, and you would like that when we do this, we have okay, something like this. Is this what you told?
Yes. I think it's the same expected, but it's not that important.
Okay. So, what is this story about?
It's the story about transferring money from two accounts that I own. I transfer money between two personal accounts. Two personal accounts, I guess.
Okay. So I'm not very happy with the names of the accounts here.
Yeah, me neither, but let's make it pass and then.
Okay. So money would be money, I think.
Money needs a value.
And if I remember correctly, we added something that was called money builder, so maybe we will use this instead.
Yes, that would be great.
Constructor. So maybe we can do this right. So at this point, maybe we need to have some money at least in the first account, because if we don't, then it's very unlikely that we will be able to transfer some money.
Yeah.
And then we'll see how we can handle this case where we don't have enough
Yeah,
money.
so let's go on the happy case. I agree.
So I have to deposit some money on my first account if I want to be able to withdraw some. And let's say we'll need to use this again. Okay, so we'll just refactor this later. And at this point, I can write the expected money amount. So my first account would have to be something like this.
Yes.
So this is very difficult to read, but
Yeah,
nice.
it's a messy test, but we'll make it nicer.
So the test should fail because we have not implemented anything. How would you like to implement this? We have several options. We can use deposit and withdraw functions.
Yeah, so I think that would be the simplest one, to use deposit on the second account and withdraw from the first account. The only thing is that these things need to happen in a transaction. If you go again, I put in my my analyst hat. So if something would happen in the second transaction of deposit, I would need to redo the withdrawal.
Yes.
Or to undo the withdrawal, sorry.
Yes, yes. What do we decide here?
So for now, I would let it like that, but we need to make a mental note that we need to take care of this in the future tests.
Okay. Okay, now the test should pass. Okay. Maybe now we can refactor this test because it's difficult to read. So I like the builder. I'm just not happy that this takes so many characters to read.
Yeah, so exactly. So we'd like to have something like a helper method, because we use it 4 times already here. So it could be money, I think. But I would keep the value, so promote that as a parameter. Great, looks a lot nicer. Now I would inline the money variable. I don't think we need it anymore.
Yes. Sorry.
And the same in the 17 and 19. A lot better.
Maybe now we just have to rename the account 1 and account 2.
Yeah, I was thinking, what's the domain terms for these? There are some domain terms, but I don't remember them.
Oh. Yes, okay. Yeah, I don't know them.
So account from which I'm searching on the other computer. From each you I think one's the credit and the other one is a debit.
Yes, that's it.
Yeah.
So debit would be the first one, I think.
No, it's the opposite.
Oh,
So credit is the one from which you take money, and 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 debit is the one on which you put money.
so that's cool. No, I think that transfer function can have better names. Yes, it can.
Mm-hmm.
Okay. So maybe at this point we can write a new test, or
Yes.
do you want to improve
I
this?
was thinking about assert that credit money is equal to money. That's not really very easy to read, but we could leave it like that and decide to do something about it a bit later, or we could do something now. What do you think?
If you have an idea right now of how we can do it better,
So
let's do it.
I would extract a helper method or a custom assert in that way to say something like, because we'll have more of these tests with transfer. Assert money was sent, money was transferred.
Oh, okay. So you want to extract both asserts into a single.
No, just one of them. Just one of any of them, but
But this one would be something like uh, assert that account as this amount of money.
oh yeah, it's true. Mm-hmm. Yeah, I think assert account has money. Yeah. Mm-hmm.
Uh,
But that's, we should
we can
have money
decide.
there as well, right?
Mm, maybe. Okay, we can.
Okay, I see what happened.
We can do this. Oh,
But it overread. Oh wow, that's why weird.
it doesn't help me at all. Okay,
Yeah,
I don't know.
that's very weird.
That's an
It should
IntelliJ. I'm
keep the value.
going to do this way.
Something's wrong. Did you
Yeah,
put them right or?
no, this way it should be better.
Great. Okay, so now we have money between two personal accounts. This is the happy path. We could either go on the negative scenarios where something's wrong and I cannot deposit deposit the money in the debit account, or something goes bad with the credit account and it should deposit in the debit account. So both of them we need to test. Or we could go further on the happy path and say I want to transfer money between one personal account to one account that's in another bank, let's say, or someone else. I don't care, but I cannot check that the other account, the debit account has money. So I just can check that I sent the money.
Okay. Uh, anyway, we're going to do both. So either way, it's okay with me. Which one would you like to try first?
Let's do this one with an account from another bank. So I think that would be interesting. It's one case where I typically would use mocks. One of the few cases where I typically would use mocks.
Okay, let's see.
So it's almost the same, but we don't have the debit account. It's almost the same as the one above.
Okay, so this is a new transfer function.
I don't know. I still have a debit account, but I cannot check
Okay.
into that account. So the debit account is different.
Okay, so this is the very same test, except that we are not allowed to do this operation.
Yeah, exactly. I mean, you cannot say that it has money. You can assert that you sent money.
Okay. So I'm thinking right now we have only one account class. Maybe it's time that we have a foreign account or other bank account. I don't know, a new concept to show that, because if just two of us know that we cannot call the assertion on the money of the debit account, maybe a third person that takes this code won't know.
Yeah.
So at this point, maybe before writing this test, we need to have a new concept of this different kind of account.
Okay, let's try to do that. It's a bit early for me, but I think it would be interesting to see how this goes.
Okay, so I'm going to remove all this, and debit would be a different kind of account. So what do we want to name it?
It's external account.
And we want to do the transfer. That would be something like this. And we would like to check that we still have 20 on our account.
Yes.
And now you're saying that you would mock and that you would like to
So
check.
yeah, you just can check until the border of your system. So that means you need to do something else. You cannot have a state test because you don't own that system.
Okay, so mocking external account here is the easy way. Would be interested in a solution that does not require
A fake.
Could we do it with a real object?
Yes, so that means that external account in this case would be a data layer or a layer. I don't know if it's a data layer. It would be a layer with the other external system.
Yeah, I'm not sure what we should do now.
That's why I said this test is a lot more interesting. Let's try either way. I could even do a kind of a study on this, or a design study, meaning that we try more alternatives and then see which one we like more.
Okay, let's do that.
So we could have a mock or a fake external account that's a layer connecting with the outside system. Those would be the options.
How do you mock usually? We can use a library that does that for us.
Yeah, I don't know in Kotlin, but typically I tend to use Mockito.
So in Kotlin, I like this one. Okay. I find it's rather easy to use. You have to take care sometimes, well, because anyway you are using mocks, so you have to take care. And it's rather easy to use. So let's use this one.
Wonderful Maven.
Okay, so maybe we can first create the external account class.
So if you use a mock, there needs to be an interface, right?
Not necessarily. Here we are not used to. We don't have to.
Okay. But don't you think it would still be advisable, or you'd prefer not to create an interface at this moment?
I would say it is too soon to create an interface because I don't know exactly where we are heading.
Okay.
But if we are using, well, no, I don't know. Actually, I can't say. Maybe it's. I have seen cases where it was not necessary to create an interface. It was okay to just have a simple class.
Okay.
So now we have to create the function transfer from an account to an external account, and now we can. I don't remember. We do this with Mockey actually. We want to make sure that we called external account deposit. So I have to look at the documentation because I don't remember how we do this. Verify. Okay.
Yeah, so it's like Mockito, it's the same thing.
Yes. So at this point, now I want to create an interface because I have to implement the deposit method from the external account class, and I don't want to because I don't know what
Yeah,
code.
exactly. That's why I was saying it's a good idea to have an interface.
So we can run the test, it should fail. And then we should implement it. Okay. So let's just, I'm copy pasting so that we really see that we are duplicating code. And let's wonder if we can do better. Okay, yes. So the interesting thing with Mockey is that by default mocks are not relaxed. So this means that if I'm calling something that I have not said I would call, it crashes.
Yes.
So here we have two options. We can either specify that it is relaxed, then it should pass, or we can specify what kind of behavior we would like our mock to have when we call the deposit method on it.
So I think, well, there are a lot of names for this concept. It's called strict or unstrict mocks. Here it's relaxed. Strict mocks means that you need to call the function, and then let's say unstrict mocks means that it doesn't care. So now, of course, this is one of the critiques with mocks, that if you are using strict mocks, you will always have this very rigid code that's always when always you connect the mocks with production code, so you have a very big coupling.
Yeah. Either way, I'm not happy with mocks in this case because, well, we are actually implementing in our tests the very same code that we will have in our function. So I understand why, but this is something that I'm not happy with because it somehow it is harder to refactor the code when I have this kind of test.
Yeah, it is, but I don't know why you're saying that it's harder to, you're implementing the same thing that you'd implement in the function, because this test is almost the same like the the test above?
Well, above we are checking that at the end our debit account has 10.
Mm-hmm.
Here we are checking that in order to our debit account to have 10, we call the deposit method.
Yeah.
Maybe tomorrow we want to call something different that has the same side effect.
Mm-hmm.
So right now we have a coupling between our test and our implementation. Because this is
It's true. Yeah.
what I don't like.
So mocks always will come with bigger coupling
Yeah.
than stubs, but still, even with stubs, you have coupling because you called the exact method, and
Yeah.
in assert you have count to money, so you still have some coupling, but you don't have coupling to the logic, meaning with the deposit function. You have coupling with the data, meaning
Yes.
with the money from the account. Let's say that maybe that change is not that fast, or it's not that problematic, because maybe you refactor a lot more often the logic than you refactor the data.
Yes. I agree. But anyway, this is the way to do
Yeah.
things. So
So that's one approach. We could try also the other approach where you have where you don't use mocks, but you'd consider the external account as being on a layer with the rest, and basically you're introducing a design layer, and that external account would create a proxy object for whichever bank it is, so it will transfer, in fact it will make the transfer. But what you can do is ask it what it received or something like that. I think this approach works, but I don't think it's very correct from the business point of view, because you expose money in the external account that you shouldn't.
yes, I agree.
So that's why I said I would prefer mocks.
Yes.
So if you want, we can write this as well, or not. If not, we can just leave the mocks and continue with the rest.
I'm not sure that it's very interesting that we will learn a lot if we write it.
Okay.
Uh, I was wondering about, but maybe this is a bit similar to what you're saying. Uh, so the fact that we have in our code we have account class, we have two different transfer methods.
Yes.
So this one is from one account to another from say bank, and the other one is from a bank from a bank to another one.
Mm-hmm.
So this means that when we deposit money here, we will very likely do some complex operation with network calls and things like this.
Mm-hmm.
And so it's very unlikely that uh, this code will be here in the deposit method. So
Yeah.
it won't probably be in the account class, and um, maybe we just want to say that the account makes a request to another entity to have some money deposited
Yeah.
somewhere, and make another request to have some money withdrawn from
Mm-hmm.
somewhere. And so this way we can test the logic and don't care whether it's a local account or an external account, because this is something that is dealt somewhere else.
Mm-hmm.
So this
Yeah.
would be another approach to.
Yeah, exactly. So I was going into that direction in a way, but still, even if you do that, I don't think any business analyst would leave you to do this. Would let you do this to add uh, a parameter or no, sorry, to add a field so that you could get money out of that structure. So it's only tell don't ask. That's how it should be done.
Okay, so let's move
But
on.
the rest, I totally agree. This is the way to go.
Okay, let's see where this leads. Uh, so let's not write test. What's the next step?
Let's see with the names of the let's go a bit to the account. Yeah, account class. We have those two transfer methods, and those are, we have some domain names there as well. The second one is transfer to external account, and the first one, okay, that's weird.
No, that's me.
And
the second.
And that one is transfer in between my accounts.
Okay. Is this only my accounts or an account and another account from the same bank?
It's in between my accounts. So there is the third situation where we need to transfer to someone else from the account who has an account in the same bank, and we can check. So that's not an external account. External account means that's from another bank.
Okay, so that would be the same tests than the external account.
No, because you don't need to use the mock. You can check.
Okay. And
because it's the same bank, you can check what the other client that has an account.
Okay. How is it different from this function?
I think it's different because you need to call the other client.
Okay.
Find the other client, find its accounts, get the account, get the amount that has now in the account, and retrieve it.
Okay, so it's different, but not in the account class. It's different when we
in the assert part.
Yeah, when we consider the clients.
Yeah.
Kind of concepts. Okay.
And probably also in the no, in the deposit, no. In the withdraw, no. It's almost the same now at this very simplistic point of view. If we go very far away, we'd have three classes. One is in between accounts, external accounts, and the same bank account.
What's next?
So let's try to do this test. I transfer money from my account to an account from the same bank.
Okay, so transfer to internal account to...
It's not internal because the other one would be internal. No, that's not internal. Yeah, let's say internal. Okay, it's fine. I think it has a name, but I don't know all the names in banking yet.
Okay. And we would like to check that our accounts has money and the same with this one. So this one would be what? An internal account?
Internal account, yes.
Okay, I think that's it. I think that we might want an interface here too, if we don't want to.
Yeah.
Repeat the same thing that we did earlier. We will. Oh, so do we mock or not? Because if we want to.
No, we don't mock, in fact.
Okay, so
I don't think we need the interface. We can have the class directly.
Okay, we have many problems. So first problem is we do not have an session for internal accounts because internal account is not an account.
Exactly.
And second problem is that we have no implementation in our account.
So let's write an assert that internal account money is equal to, oh, it's debit, yeah, it's equal to,
And at this point we have the problem that we don't have money into
yeah,
our.
let's implement that.
And by default, let's say we have no money.
Yeah.
And here I'm not very happy because
Yeah.
we wrote this, but I could have written anything else, and we have no tests that make us sure that we are doing the right thing.
Yeah, that's true. So now this one is passing? No, it's not.
It's compiling, but it's not passing because the implementation of this function has not been made yet.
Yeah.
So yes, it fails for the right reason. Let's make it pass, but actually, if I want to make it pass, I can do something very silly, like I deposit, I withdraw money from my account, and this is not what I want, but I'm doing this so that we can talk about what we do with this internal account. I could do just this, so this won't pass because I have no money on my internal account at this point, so it should fail.
Yeah.
But like I said before, I had no reason to put no money here, so and all my tests should be passing.
Yeah, it's a fun hack.
Yes, I like to find a hack in my test because when I find one, it means that they are not yet okay. Either I miss one, or many ones, or there is something that I have missed in my understanding of the problem. So what do we want to do here? Because we could write a test that tells that internal account by default has no money on it, and so then we will have to implement another version. But then if I do this, I'm starting to create a lot of duplication between internal account and account.
Exactly.
I don't want to do this.
Exactly. I would just leave it like that. It's not that important. Our purpose is to make the account statement.
Okay. Fine. So let's leave it this way. Do we want to do something else?
I would go now on the negative scenarios where I transfer money in between my accounts, but something goes bad. This is fun because we need to use a stub to generate an exception or something like that.
We can or not, because we already have these failures, which are not exceptions, when we do not have enough money on our account. So we can try to transfer money from an account which has no money on it.
Yes.
And it should fail.
Yes, so that's the first one. But not only it should fail, but the second account should not have any new money come in.
So actually,
so we can very well do that, but the other case, it would be, I think we need stubs for the other case, where we have money in the credit account, but something goes bad in the debit account.
Okay. So we have two ideas here.
Yeah.
Which one?
Well, the first one, well, that you said with the nothing happens when you don't have enough money into the credit account.
Okay. So let's transfer.
Hmm?
Something like this. So I think that writing this test this way with a credit account that has no money on it may be considered as a special case.
Yeah, so let's put 10 or something.
So we will end up with the same code, but I think that it's best to do what we're doing here for the readers.
Yeah, I don't know if it's the same code, maybe. Yeah, we'll see.
And then we want our credit to have and our debit or no money.
Mm-hmm. Yeah.
Something like this.
So it's failing.
Yes. Let's make it pass. Do you have a suggestion on how to make it pass?
I need to check. The simplest way would be to have the conditional if the money I want to transfer is more than the money I have. Then I would just respond with an error message.
Okay. Uh, this is one way. I have another way, and I don't know which one is better. We could also call the deposit method, and if it fails, then do nothing.
Mm-hmm. Okay.
Because
So
the
that
deposit.
means you put for deposit, you'd put
Oh no, sorry. We should do the withdraw first.
Mm-hmm. Yeah, we should do with the withdraw first. And if the withdraw fails, then we do nothing.
Yeah.
Yeah, I think that's nicer. It's more elegant. But what I typically am a bit puzzled with is if you have a withdraw function, I would like to keep it void rather than giving it the type of result that's boolean, and that can be kind of difficult to understand.
Uh,
That's a
yes.
design decision now. So if we can have some other way, secondary way of getting the result out of the withdraw function, like events, for example. We could have an answer, a boolean answer from withdraw saying true, false, true, yes, it was good, false, it didn't work well. Or the third way is to have an answer, to create a structure answer that to give you a package of everything that it did, like the response, it failure or success, the money that was sent, and so on. I don't know, the account number that it sent to, and so on. I prefer the last one because it's easier to understand what is there. Just by sending a true false back,
Yeah.
it can be confusing. But again, I'm thinking far away into the design. I don't know. I don't think now we do need that, but I think the decisions that we take now can affect those decisions later or a lot later.
Yes. And last time actually we already made this decision by having the reader function returning a message
Yeah,
that tells us whether it's in success
exactly.
or in failure. So we can use this or
Hmm.
not. Which one do you want to do?
I would use the message and put there, structure it in a way that it has a success sensor or something like that. success message. I don't know how to call it.
Okay. So I'm not sure to understand what you want to do. I can show you an idea. But
Yeah.
I'm not
Yeah,
this is
please.
what you wanted to do. We could do something like this. Success message. No, actually, we
It's
could
a
just do
message, I
something.
think.
If this is a failure, let's stop.
Yeah.
And that's it.
Yeah. It's a guard clause. A lot better.
Do you want to try something else?
No, it looks fine. It's really good.
So let's see your test. It seems okay.
Can you please make some empty lines in between?
Yeah.
I like to see those. I think it's easier to read.
Yes. Often I do this. So,
Yeah. For me, the empty lines are enough. Especially when you have more asserts, it starts being harder to read. If you have 3 lines of code, it's not that difficult, but when you have 7, it's not that easy.
okay. Let's have the. So we have two things we can do. We can have the withdraw method to completely fail because of an exception, and but this is not very interesting. The
No.
most interesting case is when the deposit method completely fails because of an exception.
Yeah.
Let's do this one if that's okay with you.
Yeah. So the withdrawal works, the deposit doesn't. So then we need to go back with the withdrawal and put money back and check that no money was moved in any of the 2 accounts.
When money cannot be deposited. Is this story okay?
Yeah. Looks nice.
Okay, so that should be something very similar to this one, except that we can mock the debit account and ask it to completely fail. That would be. I'm losing my mock every time we call debit deposit with anything, and we want it to throw let's say a runtime exception because I don't know what to put. Something like this.
Yeah.
So
We could also do another thing. We could make a mock on the. I'm just thinking out loud. I think that's perfectly fine, and I would do it like the same. But I was thinking about an alternative. I would. It would be to create a mock, and instead of returning an exception, have a message. Sometimes some message, a failure message, to keep it similar to the other one where we didn't return exceptions. We didn't throw exceptions.
Okay. In terms of design, I would really like that withdraw and deposit are not able to throw any exception.
Exactly. So this is what I was thinking, because now if we start throwing exceptions, it means that we're not having the same structure of the design.
Yeah. So we can decide that deposit returns something like maybe a message.
Yeah. So it would be the same thing, the failure message, I think.
Yeah. So do you want to do this first?
Yeah, I think so.
Write the test. Okay.
I think so.
So let's remove this test.
Yeah, just ignore it. You could ignore it, I guess, right? I tend to ignore them.
Actually, in uh, in my usual workflow, I would have made a commit before and
Yeah.
revamped this because I don't care rewriting things twice.
Hmm?
But I'm happy with this too. Okay, so maybe then we go back to the test of deposit money on an account, and we write a new test here that say that the well, I don't see how we can. I see how we can write that deposit money will return a success message.
Mm-hmm.
I do not see how we can write a test that would return a failure message.
There must be failures. Things like a system is not available or
So
stuff like that.
anyway, actually, I think that it doesn't really matter. Let's just say that deposit money on account returns a message, and then we will mock it so that it returns
Yeah,
a different message.
yeah, yeah.
So here we maybe will have just one new test, which would be something similar to the rest. When I deposit money account, I get message, a success message,
A
and
success
message.
message.
Okay. So let's implement this. Oh, actually, we had already this method, some money.
Mm-hmm.
So I don't know if you remember,
Oh yeah,
but
we had it. Mm-hmm.
so we will refactor this.
Yeah, yeah, yeah.
Uh, Something like this, and no, I want this to be a success message. Uh,
Do you have success message?
so I have this
Mm-hmm. Yeah.
success message, but if we use this one, then failure message is probably badly named
Mm-hmm.
because it says that I don't have enough money. So we can use this success message, but then we will have to rename
Yeah,
this one.
yeah. Probably we'll need to add another one because that's not just a failure message. That's not enough money failure message.
Something like this. Of course it fails because deposit does not return anything. Let's change this. So at this point, maybe I should run all my tests because to make sure that I didn't break anything. Okay. So I don't see how we can write a test on deposit which fails.
Why? So again, we make a stub. Let's look a bit at the deposit. We make another class account for tests that would override the deposit, and the deposit would return a failure message. So we do extract and override, more or less.
Okay, but then are we not just testing or override?
Now we're testing that the rest of the system would know how to behave in the case where a failure message would be received by the deposit. That's, I think, what we need to test. We need to test that the withdraw in a transfer, the withdrawal won't happen when the deposit didn't happen.
Okay, I completely agree with this. and I'm not quite sure that we have to write a new test on the deposit story. But
So why do you say that? When I deposit money on an account, okay. Well, I think you need another. We need another test saying that we. Yeah, not on a deposit. Yeah, for sure. On the transfer, I think you need another
yes,
test. Yeah, you're right on that. Sure.
okay, okay, very good. So actually, this is this test,
Exactly.
and here we said that we would like deposit not to throw an exception, but to returns failure message, which
Yeah.
should be well, deposit failed message, deposit operation failed. I don't know.
Deposit operation failed. Yeah.
Failed or failure, success, failed. Something like this, maybe.
Yeah.
In message, we have failure message and success message. So this would be cool.
It should need to end in message as well.
Sorry?
It would need to end in message as well if
Yes.
we use the same rule that we created until now.
So maybe we can rename this one here. I don't know if this is the right time to do this. Maybe we can come back here later.
Well, let's make a note and come back on it. Let's focus on making this test pass. But yeah, we need to do that.
Okay, so our test is not passing because
There is no answer for account get money.
yes, actually when we do fails in our session on the debit account, we try to get how many money we have here. Well, we do not have to have this session. This is something else that we have to have.
Mm-hmm.
This is that nothing else happened on the debit block.
Yeah. Okay, let's try like that. I still think we need to test that assertion as well, but maybe later.
Okay, so we have two options because here we have a mock, but maybe we don't want to mock the whole object.
Exactly.
And so this way we can test this, and this would be better.
Yeah.
Yes. I think we can do this. Let's try. Why is it passing?
Because it doesn't return the failure, I guess. So the credit, the credit you deposited, you'd like to transfer in between accounts 40. Oh, wait, you want to transfer 40. You cannot transfer 40 because you have 10. So it's...
Yeah, let's transfer 5.
Transfer 5, yeah. So it's the other case.
Yes. Okay, that's better. So now we have 5 and we should have 10.
Exactly.
Okay. That's cool.
So let's stop a bit. The difference between mock and spy is that the mock in this case, how it's written in this library, would transform the whole object into a proxy object in memory and only it will write only the methods that we explain here, like what we did in 67. So if you'd use a mock, you'd need to use to create a kind of a fake implementation for each one of the methods in that class. While with the spy, you just override the implementation that already exists by choosing those methods that you want.
Exactly. Mockito works the same way, I think.
Yeah, but by default, it's not doing. It's doing spies.
Okay. Okay. So let's make this plus. Then we should probably check what this returns and put the money back.
Yeah, exactly. So we need to check if it has a failure operation, deposit operation failure. Then we need to deposit.
And okay. So here we could actually lose some money.
Yes, if we
This
have
is going to pass, but if deposit keeps failing, then at some point this will lose money.
yeah.
How do we handle this?
Oh, typically with a transaction. So you'd have all of this method in a transaction, and you want to check that all the things are right, and you'd apply the transaction at the end, and only then all the methods would be called. So that's I think the correct way.
Okay. I have absolutely no experience in transaction over networking.
I have no idea how to do that in Kotlin, but I know how to do that in other languages.
Okay.
Typically, there are languages that have a transaction object.
Okay.
And it's enough just to put that, to say, look, I have this transaction. If there's no exception or anything, just apply everything at the end. So it's a kind of like the try catch,
Okay.
but the opposite. Like it's a transaction and then everything is good, apply changes.
Okay, I see. So for this exercise, maybe we don't do this.
Yeah, we don't. Let's not do that.
Let's accept that we can lose some money, and that's okay. Uh, what's next?
What's next? I think we have the transfer, right? Do we need to do anything about the transfer, or can we go to the
Yes,
the
maybe we
statement?
can. That I'm still not happy with this duplication here.
Mm.
Or
Yeah, we had that thing. So we had some stuff to repair. There was that thing with some money that we already had the method some money, and we created the helper method money.
yes, let's do this because it's very easy to do. Here should still pass.
And now, and then we can inline the money.
Wow.
Yeah.
Yes, so here we have 3 different implementation of transfer.
Mm-hmm.
I don't know whether it's a problem or not, but that's here.
Mm-hmm.
Uh,
I think the problem here is that we didn't write enough tests so that they will look different. So I think this duplication here is generated by the fact that we didn't write enough tests, and I would leave it like that.
okay, yeah.
Because they would diverge. So if we extract too soon, then we need to come back and inline a lot of extracted code. I don't have enough proof of what the duplication is here. I don't know.
Yeah, I agree. Yeah, I just feel that we right now are doing the same thing, but actually it's better to not utilize something too soon because you said it. We may end up with more complex code than we need. So let's keep it this way.
Okay, and there was another thing in the message class.
Yes.
Where we have failure message, deposit operation failure, which doesn't have a message at the end, and success message, which has a message at the end. So I would say at line 9 to rename that to add the known message. No, there at 9. Because you have deposit operation failure, but all the other ones have a message at the end.
Oh, yeah, sorry, I didn't understand. Yes.
Okay, and the failure message is to generic. So let's say you don't have enough money, failure
So
message.
withdraw operation for your message.
Or yeah, something like that.
So we can have the same.
Withdraw operation failure message. Okay.
Is that okay for you?
Yeah, that's great. Okay, so let's debrief a bit. So how was this the second part of our endeavor to implement this pancata with tests that tell a story?
I feel that we focused a bit less on the story part and a bit more on how we can actually write different tests with mocks, spies, and this kind of thing. And I enjoyed it because this is one of the things I wanted to talk about and play with. I'm very actually right now I'm telling myself, okay, if we introduce the concept of events in the code, maybe we can just get rid of many different things that we have done right here, like mocks and these kind of things. So that would be a very different subject, but writing this kata using an event sourcing approach would be very fun too. Now, how about the test we wrote today? I think it was easy for us to keep writing stories because we did it last time. Maybe we can still work on how we can improve a bit the readability of the code, because if you look at how there is still a few lines of code to write this, and this is not something that is very, very easy to read. I have no clue about how we could make it simpler right now, but maybe there's some more here too.
So you didn't feel we rushed through the code, it's just that now we don't have better ideas on how to refactor it?
Yes, I think at least I cannot see how we can do this in a better way.
Yeah, I think we need more tests to see how it goes along, and that's why I think I typically accept this type of let's say not necessarily bad code, but it's kind of a code entropy. Accept this while writing the tests because it's better. I learned that from experience the hard way, that it's better to leave the code like that rather than extract very often and very soon things that aren't necessarily the same. So then you start having a mess of a lot of structures that don't make any sense just because you extract it too soon.
Yes, I completely agree with this, and I was happy that you stopped me from working on the extraction of the transfer functions, because it's very clear that right now it's too soon to think about stuff like strategies or patterns like this. Maybe it will come, maybe it won't.
Yeah.
But let's not make the code more complicated for no reason.
And our purpose was to go on that list of features. We have the simplest transfer that can work, then it's not that important. If we'd like to go very deep in the transfer, probably we wouldn't reach the account statement. So that's also the thing.
Yes.
So I think it would be interesting to go kind of shallow on all these ideas from the readme file, from what we want to do next. Do everything, like then the statement printing and the statement filters, and then see if we want to go very deep into types of deposits, types of transfers, types of withdrawals, and types of accounts, and so on.
Yes, and I would be very interested in seeing how much code we rewrite, how much code we throw away, because the more we are going to understand exactly what a good design for us would be, the more the code should change. And I can enjoy actually doing this. It's not like rewriting the same code several times. It's more like you have a picture of what a good design is right now with what you know, and then when you dig deeper, you understand that actually it's not exactly how you thought it was. It's a bit different, and so your code should change. And the easier the code is to change, the better the design is. It's some kind of I don't know, a way to see if your code is good enough or not.
Yeah, sounds very interesting. So we're happy with the code we have until now. I like it. I mean there are small improvements, but I don't think we need to focus on bits of pieces.
For our current understanding of what we want to do, it's perfect. We can do better, but we can only do better when we know more about the problem we are trying to solve.
Yeah. Okay, so I guess that was all for today. Thank you for pairing with me, and see you, until next time, have fun coding.
Thank you very much. See you soon.